Dear students, in this session we are discussing about the ionic product of water. So what is meant by ionic product of water? So that's why here we are taking the water molecule. Generally water molecule dissociates into ions. So what ions are given here? It is H plus and OH minus ion. We can write the same reaction in this form also. Or we can write that is here H2O converting into H3O plus and OH minus. That's why here H plus is called which one here it is nothing but proton, or we can say here it is hydronium ion. Here this is it is a hydronium ion, and then H plus and H3O plus both are equal. That's why we can say here it is ionic product of water. So generally what we can write Ka is equal to H plus and OH minus. Ka is nothing but what here it is dissociation constant of acid. But in this case equilibrium is developed. That's why here equilibrium is given. Then we are writing the reaction like this. Here it is Ka is equal H plus concentration into OH minus ion concentration by H2. Take the cross multiplication. Ka into concentration of H2O is equal to concentration of H plus into OH minus. The product of these two is considered a Kw. So here concentration of H2O does not change. Okay, that's why here this is given Kw. What is the definition of Kw here? Ionic product, that is product of concentration of H plus and OH minus at 25 degrees centigrade. 25 degrees centigrade known as the ionic product of water. Then in this case, the ionic product of water is practically given, that is 1 into 10 to the power of minus 14 mole squared by liter squared at 25 degrees centigrade. So remember at this temperature. Then here the ionic product of water is given 1 into 10 to the power of minus 14, which is equal to concentration of H plus and concentration of OH minus. So based on this one, we can decide that is here, what is the concentration of H plus? Concentration of H plus is given 1 into 10 to the power of minus 7 moles per liter. Concentration of OH minus is given 1 into 10 to the power of minus 7 moles per liter. So ionic product of water is 10 to the power of minus 14. Then divide into two parts. Divide into two parts means minus 7 minus 7. That's why in neutral water, the concentration of H plus and OH minus is equal, that is 1 into 10 to the power of minus 7 moles per liter. So 1 into 10 to the power of minus 7 moles per liter. So this is. But if concentration of H plus and OH minus changes, the ionic product also changes. And before that, the Kw value depends on temperature. Kw depends on temperature. So that's why up to now we told it 25 only. If temperature increases, if temperature increases, the dissociation of water, the dissociation of water also increases. That's why concentration of H plus also increases. That's why here Kw also increases. If temperature increases, Kw value increases. Then in this case, based on the Kw value, we can decide three types of solutions. One is here neutral solution and acidic solution. For all neutral solution, concentration of H plus, OH minus both are equal. That is 10 to the power of minus 7 moles per liter. But if it is acidic solution, for a acidic solution, what is here? Then in this case, the concentration of H plus, OH minus not equal, H plus is greater than OH minus. H plus is greater than OH minus. That's why in this condition, what is the H plus value? That is 10 to the power of minus 1 to 10 to the power of minus 6 only. Means less than 10 to the power of minus 7. Means 10 to the power of minus 1 to minus 6 or greater than 10 to the power of minus 7. Then here concentration of H plus OH minus is minus 8 to 10 to the power of minus 14. Okay, that's why for all acidic solutions, concentration of H plus is 10 to the power of minus 1 to minus 6. Concentration of OH minus is always 10 to the power of minus 8 to minus 14 for all acidic solutions. And next one, third one is basic solutions here. Basic means alkaline solutions here. For all alkaline solution, what is here the H plus OH minus concentrations? H plus concentration is less than 10 to the power minus OH minus. So that's why based on this one, what we can say here it is concentration of H plus is 10 to the power of concentration of H plus is 10 to the power of minus 8 to minus 8 to 10 to the power of minus 14. For concentration of OH minus is 10 to the power of minus 1 to minus 6 actually. Minus 6. This is here the based on the H plus OH minus concentration. The ionic that is here acidic nature, basic nature, neutral nature is given for a given solution. But we already told you product of, what is the definition of KW? Product of concentration of H plus and OH minus. That's why we discuss some more information about this one here. So that's why here I'm giving the KW here scale. So what is here the KW scale given? So this is here 10 to the power of minus 1 to minus 7 and minus 14. This is nothing but what? Concentration of H plus. Based on the concentration of H plus is given. Minus 1 to less than minus 7 is acidic in nature. Acidic nature or acidic solution. Minus 7 exactly neutral solution. And then minus 7 above greater than minus 7 known as a alkaline, that is the basic solution. That's why based on this one we can write here. But based on this one we can write a one question suppose. What is the question? For a given solution, concentration of H plus is 1 into 10 to the power of minus 6 moles per liter. What is the concentration of OH minus? That is the question. Then we already know that is here KW is equal to concentration of H plus into OH minus, but which is equal to 1 into 10 to the power of minus 14. So this value is given, we want to calculate this value. So that's why what we can write concentration of OH minus is equal to 1 into 10 to the power of minus 14 by which one here? Concentration of H plus. This is here the relation. Like this, we can calculate the concentration of OH minus. Then substitute the value in this case 1 into 10 to the power of minus 14 by 10 to the power of minus 6. Then take this value minus 14 into plus 6, then 10 to the power of minus 8 moles per liter. That's why here for any solution, the KW value is maximum 10 to the power of minus 14 at 25 degrees centigrade. But generally, the concentrations are expressed very low, minus values. So that's why here practically getting the problem to indicate the concentrations in negative terms. That's why here a new scale is introduced, which is known as a pH scale. So that's why here, what is here the pH scale we are discussing. So that's why to avoid the negative terms of this one, we are taking a new scale, that is here the pH scale. pH scale introduced by pH scale introduced by whom here? pH scale introduced by Sorensen. Sorensen introduced the pH scale. But what is meant by pH? pH means here it is power of hydrogen. pH means here it is power of a hydrogen here. So power of P means here it is a power. But exact meaning in German. So that is here P means it is a P is nothing but potence. Potence. Okay, this is in German language. In German language, P means potence, and then P indicates what is the meaning of potence? Power. That's why here nothing but P is a power. And finally, what is meant by pH here? It is power of hydrogen. Power of hydrogen is a pH. But what is the definition of pH here? It is pH is given like this here minus log H plus ion concentration. So this is here the pH equation. So based on this one, we can give the definition also. And before that, we are writing the same equation in this form. pH is equal to log 1 by concentration of H plus. So that's why here you can understand this word, but it is if you take this H plus to the numerator, converts into minus. That minus is given in front. That's why here it is pH is equal minus log H plus or log 1 by H plus here is concentration. Then what is the definition of this one? Based on this one, the negative logarithm of concentration of a H plus ion, negative logarithm that to base 10, we should use base 10 compulsory. Negative logarithm of base 10, that is negative logarithm of concentration of H plus ion. H plus ion is nothing but a pH. So this is the definition of a pH here. But based on this one, suppose here the concentration of H plus is given for any problem, that is 10 to the power of minus 2. Then how to write the pH of this one? Minus log 10 to the power of minus 2. Then this minus 2 will come in front here it is. That is 10 to the power of minus 2 means minus plus 2 log 10. So 2 log 10. Log 10 means nothing but what? 1. That's why here pH is equal to 2 for the given solution. So this is a way to calculate the pH of a given solution. But a problem is given. Before that, I'm giving a scale, pH scale for this one here. So what is the pH scale here? It is 1 and 7. This is a 14. Less than 7. That's why here. So what we can say here it is pH value 1 to less than 7. Okay, 1 to less than 7, 1 to 7 is acidic nature. That's why here that solution is having the acidic nature. Then pH exact 7 is here it is neutral solution. That solution is a neutral solution. pH greater than 7 here it is. Greater than 7 means nothing but what we can say 7 to 14. That is known as a basic solution or alkaline solution here. So that's why here, why we are taking 1 to 14 in the pH scale, it given based on Kw only. We told what is this one concentration of H plus is given 10 to the power of minus 1, minus 7, minus 14. So that's why here we told this one pH value is given 1 to 14. Then the pH scale is given like this. But in this case, we are taking that is here a problem is given based on this one. Concentration of or molarity of a question is given. So before that, I'm removing this one here, or we'll discuss here only. Molarity of HCl aqueous solution is given 10 to the power of minus 8 molar. Calculate the pH of given solution. Calculate the pH of given solution. This is the question. So that's why according to concept, what is this one? HCl converts into which one? H plus Cl minus. What concentration is given for HCl? HCl is minus 8. That's why H plus also minus 8. Cl minus also minus 8. That's why we can take concentration of H plus is, that is here 10 to the power of minus 8 moles per liter. But if we substitute this value in this equation, minus 8 means minus log 10 to the power of minus 8 will get the 8. But pH of the given solution is the 8. 8 means nothing but what here it is? Basic nature, that is alkalinity. So here, alkalinity. So alkalinity means nothing but what we can take here it is alkaline in nature. But the given solution is not a base, it is an acid. That's why for given solution, pH value does not 8. It is not a 8 here. But how to calculate this one here? That's why here in this solution, the solution is given 10 to the power of minus 8 means very low concentration here it is. So that's why here in this one we should consider water also. We should consider water. Water is giving which one here it is H plus and OH minus ions. Generally concentration of H plus OH minus ion in water, what we can take 10 to the power of minus 7 and minus 7. That's why concentration of H plus is given minus 7. This is given by what? Water. Concentration of H plus given by what? HCl minus 8. That's why the total concentration of H plus is nothing but what here it is 10 to the power of minus 7 plus 10 to the power of minus 8. We should compulsory add these two values. This is here the concentration of H plus total. Then now we should substitute in this one here. Before that, take the common of minus 7. Then this is a 1. Then this is here the minus 1. Means 1 by 10. 1 by 10 means 0.1. That's why 1.1 into 10 to the power of minus 7 moles per liter is a concentration of H plus. Then we should substitute this value in the pH scale, in the pH equation. That's why here in the pH equation, we should substitute this value. We'll get here the pH of a given solution here. That's why here I'm removing this one. Then after that, we'll substitute. So that's why here it is. We are taking that is here the. So finally, what is this one? pH is equal minus log 1.1 into 10 to the power of minus 7. Then again same method, log AB, log A plus log B. That's why minus log 1.1 and plus A. Plus means we can get minus only here it is. Why it is here minus is present in front of this one here. That's why we can take minus log 10 to the power of minus 7. Minus 7 will come from here 7 log 10. 7 log 10 means we can take 7 minus log 1.1. That's why here we'll get approximately the pH of this one is 6.9. Okay, 6.93. Okay, 94 or we can take here it is 6.97 we can get here. And this is here the pH of a given solution for this one. So that's why what we got the pH of this one, it is 6.97 suppose here. So finally what we can get here it is, this is 6.97 means less than 7 only. That's why we can consider the pH of the solution is 6.97. This method is not correct for these type of solutions. That's why here for any acid, if the pH plus concentration is given 10 to the power of minus 8, minus 9, minus 10, for those type of problems, we should use this one compulsory. So this is here the calculation of pH for the given problem, and pH scale is also given. And then here, suppose we are taking other example based on this one. So what is the example of this one? Concentration of H2SO4. H2SO4 is 0.2 into 10 to the power of minus 2 moles per liter. Calculate the pH of the given solution. So calculate the pH of a given solution. This is so in this case here, How to write the answer? Generally, first of all, what we can write, H2SO4 decomposes into which one? H plus and 2H plus, next one SO4 minus 2. Concentration of this one is 0.2 into 10 to the power of minus 2. That's why this is also 2 into 0.2 into 10 to the power of minus 2. Then we can get 0.4 into 10 to the power of minus 2. So that's why here in this step, in this problem, we'll end this part. That's why here, how many H plus ions are given? We should multiply with that. That's why here it is 0.4. Now we can calculate the pH of the given solution here. pH of given solution. That is here minus log 0.4 into 10 to the power of minus 2 here. Then what we can write here, it is 0.4. If we remove the point, what we can get? Log 4 into 10 to the power of minus 3. Then log 4. 4 means what we can write? 2 squared, log 2 squared minus log 10 to the power of minus 3. That's why we can get 3 minus 2, okay, 2 log 2. But what is the value? 3 minus 2 into log 2. Log 2 value is 0.3010. That's why here 3 minus the 0, 2 and 0, 6. That's why this is here. So approximately what we can get here, it is 2.4 is a pH of the given solution. That's why here this is a way to calculate the pH of a given solution. But if they gave one more problem based on this one, that is here, for a given solution, pH is given. For a given solution, pH is given 6. Calculate the pOH here it is. That is the question. Simple problem here it is. For a given question, pH is given 6. We want to calculate the pOH. So how to calculate the pOH? We should know compulsory. We are learning one equation based on this one. For any solution, pH plus pOH is always equal to 14. For any solution, pH is always equal to, pH plus pOH is always equal to 14. That's why what we can get, pOH is equal 14 minus pH here it is. 14 minus it is here the 6 here. That's why we can get 8 only. That's why pOH of the given solution is 8. So if we know the pH, we can calculate the pOH. If you know the pOH, we can calculate the pH. So this is here the way to calculate the pH and pOH of a given solutions. And like this here, we can calculate the number of problem. Last problem is based on this one here we are taking. That is here 4 grams of NaOH dissolved in 4 grams of NaOH dissolved in 500 or 100 ml of solution, 100 ml of water that is here. So 100 ml of aqueous solution. Calculate the pH of the solution here it is. But in this case, first of all, we have to calculate the concentration of OH minus, that is molarity. But generally, what is the molarity principle here? It is weight by gram molecular weight into 1000 by volume of solution. This is a molarity principle, weight by gram molecular weight into 1000 by volume. Weight is given how many grams? Here it is 4. Gram molecular weight of NaOH, that is a solute. That's why gram molecular weight of NaOH is a 40. How it is here? Sodium 23, oxygen 16, hydrogen 1. Then into 1000 by volume 100 ml. 0, 0 cancel, and all zeros are cancelled. 4 also cancel. That's why what the molarity of given solution here it is 1. Means nothing but concentration of OH minus. So here concentration of OH minus is given 1. Then calculate the pOH. So that's why here we are changing a small change is given in this case here. That is, suppose I am taking 0.4 grams. 0.4 grams is considered in this problem. Then what we can get here, it is 1 by 10. If we remove the point here, that is 1 by 10, or we can take a 0.1. So 0.1 means here it is That is here 10 to the power of minus 1. Concentration is 10 to the power of minus 1. Then based on this one, we can calculate. So we can calculate here it is concentration of H plus concentration of H plus. We know the OH minus. Then concentration of H plus means nothing but what? 10 to the power of minus 14 by OH minus. 10 to the power of minus 14 by 10 to the power of minus 1. Then what we can get? 10 to the power of minus 13. Then finally pH is equal to, we can write minus log 10 to the power of minus 13. That's why we can get 13 log 10 mean 13. That's why here the pH of given solution, it is a 13 because it's a base. We know this is here the base which is giving the OH minus. That's why here the pH of given solution is a 13. But we'll get the pOH. What is the pOH of given solution? It's compulsory 1. 14 minus 13, that is a 1. Or we can calculate pOH by this method also. What is the pOH? Here it is minus log OH minus also. Minus log OH minus. This is here the pOH equation. Okay, this is here the pOH equation. And this is here the way to calculate the pH of a given solution. So like this, we are giving a general equations for all those here. Finally, I'm writing that is here pH is equal minus log H plus. Next one, pOH is equal to minus log OH minus. Then pKW is equal to, that is minus log KW. Then pKa is equal to minus log Ka. Then pKb is equal minus log Kb. So these are the equations useful in different types of problems here. So this is here the pH problems, and remaining part of pH we'll discuss by next session. I think all of you understood here, and then we'll discuss the remaining part by next session or next class. Thank you.